In a residential panel that is not a subpanel, it is a code requirement to terminate the neutral and ground conductors from a single home run in separate holes on a common neutral ground bar. This requirement is outlined in the National Electrical Code, specifically section 250.24 FIV. This section addresses grounding requirements for services and emphasizes the connection of both the neutral conductor, also known as the grounded conductor, and the equipment grounding conductor to the same grounding bus within the panel board. This means that when a single circuit or home run is wired from the panel to a specific outlet, light fixture, or appliance, the neutral wire and the ground wire must each have their own distinct termination point on the panel's grounding bus bar. The purpose of this requirement is to ensure a safe and effective path for fault current, minimizing the risk of electrical shock and fire hazards. When the neutral and ground conductors are properly separated and connected to the grounding bus, any fault current, such as that resulting from a short circuit or insulation failure, will have a low impedance path back to the source. This low impedance path allows the overcurrent protective device, such as a circuit breaker or fuse, to quickly detect the fault and interrupt the circuit, disconnecting the power and preventing a sustained electrical hazard. If the neutral and ground conductors were improperly connected, such as being combined under a single terminal or connected to different grounding points, the fault current path could be compromised. This could result in a higher impedance, which would slow down the response time of the overcurrent protective device, potentially allowing a dangerous voltage to persist on the metal parts of electrical equipment, creating a shock hazard. Furthermore, an improper connection could lead to circulating currents and the grounding system, which could cause nuisance tripping of circuit breakers, electromagnetic interference, and even overheating of conductors and equipment. The grounding bus bar itself is typically a metal bar that is securely bonded to the panel enclosure and connected to the grounding electrode system. The grounding electrode system consists of one or more grounding electrodes, such as ground rods, metal water pipes, or concrete encased electrodes that are buried in the earth and provide a direct connection to ground. This connection to ground provides a stable reference point for the electrical system and helps to equalize the voltage potential between different parts of the system, reducing the risk of electrical shock. The grounding bus bar in a residential panel is designed to accommodate multiple terminations, providing separate holes or terminals for each neutral and ground conductor. These terminations are typically made with screws or compression connectors that ensure a secure and reliable electrical connection. It is important to use the correct size and type of connector for the conductor being terminated and to tighten the connectors to the proper torque specification to ensure a good electrical connection and prevent overheating. When installing or maintaining electrical wiring in a residential panel, it is crucial to follow all applicable codes and regulations, including the requirement to terminate neutral and ground conductors separately on a common grounding bus bar. This helps to ensure the safety and reliability of the electrical system and protects occupants from electrical hazards. In addition to the basic requirement of separating neutral and ground conductors, there are a few other considerations to keep in mind when working with residential panels. Firstly, it is important to properly identify and label all conductors. This includes marking the neutral conductors with white or grey insulation and the ground conductors with green insulation or bare wire. Proper labeling makes it easier to trace circuits and identify potential problems. Secondly, it is important to ensure that the panel enclosure is properly grounded. This is typically done by connecting a grounding conductor from the panel enclosure to the grounding bus bar. This helps to protect against electrical shock in the event of a fault within the panel. Thirdly, it is important to avoid overloading circuits. Each circuit in the panel is designed to carry a specific amount of current, and overloading a circuit can cause the circuit breaker to trip or, in more severe cases, can lead to overheating and fire. To avoid overloading circuits, it is important to distribute the electrical load evenly among the different circuits in the panel. The National Electrical Code, or NEC, is a comprehensive set of standards for the safe installation of electrical wiring and equipment. It is updated every 3 years by the National Fire Protection Association, or NFPA, and is widely adopted by states and local jurisdictions. The NEC covers a wide range of topics, including grounding, wiring methods, overcurrent protection, and equipment installation. It is an essential resource for electricians, electrical inspectors, and anyone else involved in the design, installation, or maintenance of electrical systems. Section 250 of the NEC deals specifically with grounding and bonding requirements. This section covers a wide range of topics, including grounding electrode systems, equipment, grounding conductors, and bonding of metal parts. It is important to consult Section 250 of the NEC for detailed information on grounding and bonding requirements for specific applications. In addition to the NEC, there may be other applicable codes and regulations that must be followed. These may include state or local building codes, as well as regulations from utility companies. It is important to check with the local authorities to determine which codes and regulations apply to a specific project. When working with electrical systems, it is always important to take safety precautions. This includes wearing appropriate personal protective equipment such as safety glasses and gloves, and using insulated tools. It is also important to de-energize circuits before working on them, and to verify that the circuits are de-energized using a voltage tester. Working with electricity can be dangerous, and it is important to take all necessary precautions to protect yourself and others. If you are not comfortable working with electricity, it is best to hire a qualified electrician to do the work. A qualified electrician will have the knowledge and experience to safely and properly install or maintain electrical systems. Firstly, ensure the panel is properly rated for the incoming service. Secondly, verify that all connections are tight and secure. Thirdly, clearly label all circuits. Fourthly, use appropriately sized conductors for the load. Fifthly, never overload circuits. Sixthly, test ground fault circuit interrupters and arc fault circuit interrupters regularly. Seventhly, keep the panel free from obstructions. Eighthly, maintain a safe working distance from energized parts. Ninthly, always follow the National Electrical Code and local regulations. Tenthly, when in doubt, consult a qualified electrician. Proper grounding is essential for electrical safety. It provides a path for fault current to return to the source, allowing overcurrent protective devices to trip and de-energize the circuit. This helps to prevent electrical shock and fire hazards. The grounding electrode system is the foundation of the grounding system. It consists of one or more grounding electrodes that are connected to the earth. These electrodes provide a low impedance path to ground, which helps to stabilize the voltage potential of the electrical system and reduce the risk of electrical shock. The equipment grounding conductor is a conductor that connects the metal parts of electrical equipment to the grounding system. This conductor provides a path for fault current to return to the source, allowing overcurrent protective devices to trip and energize the circuit. Bonding is the process of connecting all metal parts of an electrical system together to create a continuous electrical path. This helps to equalize the voltage potential between different parts of the system and reduce the risk of electrical shock. In addition to the specific requirements of Section 250.24 of FIV, there are other relevant sections of the NEC that address grounding and bonding in residential panels. These include Section 250.4, which covers general requirements for grounding and bonding, Section 250.28, which covers bonding of metal water piping, and Section 250.50, which covers grounding electrode systems. It is important to consult these sections of the NEC for detailed information on grounding and bonding requirements for specific applications. Proper grounding and bonding are essential for electrical safety. They help to prevent electrical shock, fire hazards, and equipment damage. By following the requirements of the NEC and taking appropriate safety precautions, you can help to ensure the safety and reliability of electrical systems. The common neutral ground bar typically must be bonded to the metal enclosure of the service panel. This bonding ensures that the enclosure is at the same potential as the grounded neutral conductor, further enhancing safety. The size of the grounding electrode conductor, which connects the grounding electrode to the neutral ground bar, is determined by NEC Table 250.66 and is based on the size of the service entrance conductors. Proper sizing ensures that the grounding electrode conductor can adequately carry fault current back to the source. Subpanels, which are fed from the main service panel, require a different grounding configuration. In a subpanel, the neutral conductor must be isolated from the enclosure and the separate equipment grounding conductor must be run back to the main service panel. This prevents neutral current from flowing on the equipment grounding conductors, which can create a shock hazard. The overcurrent protection devices, such as circuit breakers, are designed to protect the conductors from overloads and short circuits. These devices are rated in amps, and it is important to use the correct size circuit breaker for the circuit being protected. Using an undersized circuit breaker can result in nuisance tripping, while using an oversized circuit breaker can allow the conductors to overheat and potentially cause a fire. Arc fault circuit interrupters, or RFCs, are designed to detect arc faults, which are a common cause of electrical fires. RFCs are required in many residential circuits, particularly those that serve bedrooms and living areas. Ground fault circuit interrupters, or GFCIs, are designed to detect ground faults, which can cause electrical shock. GFCIs are required in areas where water is present, such as bathrooms, kitchens, and outdoor receptacles. When installing wiring in a residential panel, it is important to use the correct wiring methods. Non-metallic sheath cable, or NM cable, is commonly used for residential wiring. NM cable consists of 2 or more insulated conductors enclosed in a non-metallic sheath. Conduit, which is a metal or plastic pipe, is also used for residential wiring. Conduit provides additional protection for the conductors and is required in some applications, such as underground wiring. When making connections in a residential panel, it is important to use the correct connectors. Wire connectors, such as wire nuts, are used to join conductors together. These connectors must be properly sized for the conductors being joined and must be tightened to the proper torque specification. Terminal blocks are used to terminate conductors on devices such as circuit breakers and switches. These terminal blocks must be properly sized for the conductors being terminated and must be tightened to the proper torque specification. The National Electrical Code provides detailed requirements for the installation of electrical wiring and equipment. It is important to consult the NEC for specific requirements for your application. The NEC is updated every 3 years, so it is important to use the latest edition. In addition to the NEC, there may be other applicable codes and regulations that must be followed. These may include state or local building codes, as well as regulations from utility companies. It is important to check with the local authorities to determine which codes and regulations apply to a specific project. When working with electrical systems, it is always important to take safety precautions. This includes wearing appropriate personal protective equipment, such as safety glasses and gloves, and using insulated tools. It is also important to energize circuits before working on them, and to verify that the circuits are energized using a voltage tester. Working with electricity can be dangerous, and it is important to take all necessary precautions to protect yourself and others. If you are not comfortable working with electricity, it is best to hire a qualified electrician to do the work.